An introduction to electrostatics. We're about to start a new unit here in which we start talking about charges. We'll get to that in a minute. But we can start categorizing materials that we see into two categories. We can call them conductors or insulators. A conductor is an insulator that allows electrons to pass through that material. And you'll notice that I put the terms through in quotes here. Because when I want you to think about conductors, I don't want you to think that it's a pipe that electrons go whizzing down, like a lot of people would think of through. In addition, let's think of this analogy. Let's say that I line 3 students up here, and I have them stick out their hand, and I put sweet tarts in each one of their hands. And I tell them, you can't be holding more than 2 sweet tarts. So I put 1 additional sweet tart into this student's hands. Now he has 3 sweet tarts. What's he going to do? He's going to turn to the student next to him and say, here, take this for me. And that student will take an additional sweet tart. Now they have 3 sweet tarts. They're going to turn to the student next to them and go, here, take this for me. And so on and so on and so on. And in that way, electrons are allowed to move down an insulator. Now, if you replace those students with atoms, and the sweet tarts with electrons, when the first atom gains an additional electron, it turns to the atom to the next of it and says, here, take this electron. And that atom goes, here, take this electron, so on and so on and so on. So conductors move electrons down through the material. It can also transfer a charge, which we'll discuss in a little bit. Some examples: copper. Copper wire is a very good conductor of electrons. In general, you can say that conductors are usually metals. The flip side, if we think about it the other way around, insulators are those materials that don't allow electrons to pass through it. In our student analogy, I put a sweet tart in the first hand. He turns to the next student and goes, here, take this. And that student says, no, I'm not going to take it. That's the way insulators work. You can add an electron to one particular atom of an insulator. Be honest with me. During the winter, do you ever scuff your feet on a carpet floor and then walk up and shock your brother or sister? Why does that work? Well, here's the reason why. We call it a static charge. And a charge is simply a region in which there is a buildup or a deficiency of electrons. Now, by the way, did you notice that I put parentheses E negative sign? That's kind of a shorthand way of writing electron. So in your notes in the top right hand corner, why don't you write E negative sign equals the word electron. You can use it as shorthand. So okay, have you ever done this? Take a party balloon and rubbed it on your clothing and then stick it to the wall? The reason why has to do with this idea of charge. Now, if this party balloon, before you rub it, now you can see that there are positive charge, protons, and negative charges, electrons. And you know what? They're mixed up. They're very, very random. But there's the same number of negative charges as positive charges. The term that we use for this type of balloon is neutral. In other words, there's no region of buildup of electrons, there's no region of deficiency of electrons. We call this neutral. But if I take this balloon and I rub it on my clothing, basically I rearrange the way in which these particles are ordered relative to each other. On one side, I have a lot of negative ions, negative electrons. Not to say that there's no positive ions on this side, or protons, but there's just a lot of them that happen to be on one side. And on the other side of the balloon, there happens to be positive charges. Not to say that there's no negative, but the positives way outweigh negatives. And we call this charged. It has a region of negative, a lot of electrons, and a region of deficient of electrons. We call those regions with high electrons a negative charge, and those regions with very few electrons, negative charge. What's interesting is both conductors and insulators can be charged like this. But what happens when you charge a conductor? Like, for example, if as opposed to having a balloon that's made out of rubber, which is an insulator, right? Rubber's an insulator that doesn't allow the electrons to move over the surface. What would happen if I did this to a metal sphere, like a metal ball? If I charged it up so that this side didn't have very many electrons and this side had a lot of electrons, because it's made out of metal and it's a conductor, what happens to these electrons? They can move. They can move all over, and very quickly. It goes from a charged circumstance to a neutral circumstance. And so the conductors allow the electrons to move around as they go. This idea is really based on the idea of opposites attract. Now, you might have heard this in relationships, right? That people who are very much opposite tend to stick together or date even. And if we flip that around, that means that likes repel. Well, we can talk about that in a physics sense as well. So, a positive and a negative charge, those things tend to attract to each other, want to move towards each other. But if you bring a negative charge close to a negative charge, they're going to push away from each other. The flip side is if you bring a positive next to a positive, they're going to push as well. And so that's how we talk about opposites attract and likes repel in physics.